Good morning, guys. So in this video we'll start solving the truss problem by using the method of sections. Here, guys, you can see all the steps to solve for the method of sections. First of all, you should decide how you need to cut the truss. Decide which side of the cut truss will be easier to work with, and this is of course by knowing the number of unknowns. If required, determine any necessary support reaction by drawing the free body diagram of the entire truss and applying the equations of equilibrium. So if in both sides, guys, we have some reactions, we should find them first, and this is of course by taking the whole truss as our free body diagram. And then once we know our reactions, we should go to step 4, which is draw the free body diagram of the selected part of the truss, and then apply the scalar equations of equilibrium to the selected cut section of the truss, which are sum of x, sum of phi, and sum of moment around any point to solve for the unknown member forces. So these are the steps of method of sections. Let's apply them now to this problem. So as you can see here, guys, in this problem, I have a truss. Because I don't have any force on any member, all my forces are on the joints. And this truss is supported by a pin here, which means I have two reactions. I can assume any direction for these two reactions. And a ruler here, which means I only have one reaction. And then, guys, the question is to find the internal forces inside member GE, GC, and BC. So of course, my section will be as this one. Now I will call this AX, AY, and this is DY. All the dimensions, all the necessary dimensions are different. AB is equal to BC is equal to CD is equal to 4, and the height is equal to 3 meters. So I can do the projections of forces. Now here, guys, if this is my left part, and this is my right part, I can see, guys, that in both cases, in both parts, I have 3 unknowns in addition to the reactions. So if I take the left part, I have 1, 2, 3, 4, 5. If I take the right part, I have 1, 2, 3, 4. So basically, guys, I cannot do my cut before finding the reactions. How to find these reactions? It is basically by drawing the free body diagram of the whole truss and find them. So guys, I will erase this cut. Take my free body diagram of the whole truss and let's find AX, AY, and DY. So I know, guys, that the sum of forces is equal to 0, which means AX plus 400 Newton is equal to 0, and this means that AX is negative. I know that the sum of Fy is equal to 0, which means that AY plus DY minus 1200 is equal to 0, which means that AX plus DY is equal to 1200. AY plus DY is equal to 1200. And the third equation is the sum of moment. What I can do, guys, is to take the sum of moment around A to get rid from these two reactions. And then the forces that I have are 1200, 400, and dy. So I can assume that the counterclockwise is my positive direction, which means, guys, that 1200 is doing a negative direction. So 1200 times 8. 400 is also doing a negative direction. So minus 400 times this distance, which is 3. And finally, dy is doing the positive direction. So plus dy times 8, 12 is equal to 0. So I can directly find dy from here, and basically it is positive. So dy is 1200 times A plus 400 times 3 over 1200 newtons. Now guys, if I know dy, I can find AY. And this means, guys, that AY is equal to 1200 minus 900, so it is positive 300. Okay, so this is how I can find all my reactions by applying the equilibrium equations on the whole truss. And then, guys, I can put them in the correct direction and then redo my part. So let's do it. Okay, so these are my reactions in the correct direction. And now, guys, I can do my cut another time, and then I can decide which is the easiest part to apply the equation of equilibrium. I have the left part and the right part. In fact, guys, here the easiest part is the left part. Why? Because I only have two external forces, AY and AX, while the right part has 1, 2, 3 external forces. And this means, guys, that this part is the easiest one. So let's take the left part. So this is, guys, my left part. Now I can assume that all my internal forces are in tension. So they are going out from my member, pulling it out. Okay, so this is FGE, this is FGC, and this is FBC. So all my forces are now in tension. If any of them is negative, this means that it is in compression. And this is, guys, an advantage of this method over the method of joint, because I can directly predict if my member is in tension or in compression. I don't have to flip it. I know that even in the method of joints, I can directly know, because in fact, if I know that the joint is in compression in this member, then this member is also in compression. But here, guys, I'm showing the internal forces directly on the members, okay? So these are my forces. I only have two reactions, so I only have two external forces. Now I can start by applying the sum of Fx, sum of Fy, and sum of moments. I can, guys, start by the sum of moments around a specified point that can allow me to get rid of two unknowns. What is this point? Basically, this point should be the point of intersection of two unknowns, like G. So if I do sum of moment around G is equal to 0, I will get it from this one, and then I can find FBC. I will also assume that the counterclockwise is positive, which means FBC times the height, which is 3, because this is a 3 in fact, and this is 4, minus 400 times 3 minus 300 times this distance here from A to G, which is 4, is equal to 0. And this means, guys, that FBC is equal to 800 newtons. This is my first unknown, and fortunately it is positive, so this member is in tension, so I can write that this is 800 newtons. So from the sum of moments around G, we found that FBC is positive, so it is in tension because my assumed positive direction is the tension, and it is equal to 800 newton. Now let's find the remaining two unknowns, FGE and FGC. I will start basically by the sum of Fy. Why? Because in fact, sum of Fy will give me FGC since FGE is in X direction. You can of course start by sum of X. You will have two unknowns in the same equation, and then sum of Fy, you will have one unknown in this equation, and then find FGC, put it in the equation of sum of X is equal to 0. It is the same. Sum of Fy is equal to 0 will give me that 300, which is basically the reaction of A minus the projection of FGC on Y, so minus FGC. What is the projection of FGC on Y? Basically, guys, I know that this is equal to 4 and this is equal to 3. Then this should be equal to 5 radical 4 squared plus 3 squared radical 25 is 5, which means, guys, that the projection of FGC on Y will be the sine of this angle, so 3 over 5. And this will be equal to 0. So this means, guys, that FGC will be equal to 5 times 100, 500 Newton in the positive direction, which means, guys, that also FGC is in tension and it is equal to 500 Newton. My remaining force is FGC, and I will find it using sum of Fx is equal to 0, which means, guys, that minus 400, which is AX, okay, it is in the negative X, plus 800 Newton, which is FBC, plus the projection of GC on X prime, which is 500 times 4 over 5, so the cosine of this 4 over 5, plus FGE is equal to 0. And this means, guys, that basically FGE will be equal to negative 800 Newton. And this means, guys, that the only force that is in compression, or the only member that is in compression, is basically the member GE. This is my force here. It is in compression and it is equal to 800 Newton. Guys, you can do the same problem by using another procedure. For example, let's say I want to apply the equilibrium equations on the right part, which is this one. So guys, this is the second step. In the second step, I should decide which part I need to work on. So let's say I decided that my part is the right part. And then I take a look on this part. I found that I have 1, 2, 3 forces. I will assume that they are all in tension. So 1, 2, 3 internal forces in tension, and they are unknown. And I have an additional unknown here, which is dy. So I need basically to take my whole truss to find dy, and then to do my cut, and then to find the internal forces. Since, guys, my objective is to work on the right part, and I know this objective from the beginning of my solution, then what I can do, guys, is whenever I take this free body diagram as my whole truss, I can find the sum of moment around A to get rid from these two reactions only. So I can apply only one equation, which is the sum of moment around A, get rid from these two reactions, find the reaction at D, which is dy, and then directly, guys, I don't need to do sum of X, sum of Fy on the whole truss. Directly, I can go to my right part, and then I can find these internal forces. They have to be of the same value. And if one member was in tension in the left side, so in my method, one member was in tension. In your method, if you apply the equilibrium equations on the right side, you will have the same answer. This member is in tension and it has the same value of the force. And one small note, guys. If you remember, when we take the sum of moments around G, we found the force at the member FBC. You can also, guys, take the sum of moment around C, even if you're not seeing C because you are taking the left part. So even if you're not seeing C, but you know that these two forces are concurrent at the point C, you can take the sum of moments around C, and then you can get rid from these two forces and find the force directly inside the GF. And the same goes to the left side, to the right side, sorry. I can take basically the sum of moment around G, which is the intersection of GC and GE, and even if you're not seeing the point, but you know that these two forces are concurrent on this point, you can do the sum of moment around this point, because in fact the equation of the sum of moment is valid for any point on this truss. Thank you.